Hey there, Mr. Sutton here, bringing you the Pre-Cal Honors 8-2 Extra Practice number 3 solutions on arithmetic, series, and sigma notation. This one's got a puzzle that goes with it, so let's check that out. For this puzzle, we're trying to solve the riddle, what is the sun's other job? So we have to solve all these questions having to do with arithmetic sequences and series. There's a huge variety of them, so we'll just take them on kind of a case-by-case basis. Once we get the answers, we look for those over here on the right in this column, and whatever letter goes with that number, we put that letter above the number down here in the blanks below. And then it'll spell out the answer to this puzzle. So let's go ahead and follow the sun on this one. For the first problem, we're trying to figure out the 11th term in this arithmetic sequence. So probably the fastest way to do this in general is to use the formula. So we have a sub n equals a1 plus d times n minus 1. And this is based off of basically a linear sort of pattern. You can think of this d as kind of your slope, and this a1 is essentially your y-intercept. So to do this, we have to figure out first off what's our first term, which is -7 in this case. Our common difference, that's what I have to keep adding to get to the next number. And you can find that by taking one of the terms and subtracting the term before it. So -3 minus -7, that's really a plus 7, which comes out to 4. So we're essentially adding 4 each time that we move forward in this sequence. So for my d value, I've got 4. And then for the n, that's the number of the term that you're trying to find. In this case, that's 11. So we'll do 11 minus 1 there. And then the rest of it is just crunching the numbers. So this one we can probably do without a calculator. I mean, 11 minus 1 is 10. 4 times 10 is 40. And -7 plus 40 gives us 33. Let's find that answer over here. I split up my column so I could fit it all in one place. 33 goes with H, so 1 is H. For number 2, we're trying to find the 26th term for this sequence. Again, it's arithmetic, so I'm going to use my a sub n formula to find the nth term. So I'm doing the 26th term. This time around, my first term is going to be 1, plus my common difference, 7/3 minus 1, that's really 7/3 minus 3/3, which would give me 4/3, so that's kind of a weird d value, but we'll have to use it. And then I want 26 for n, the nth term. And I'm going to do this in my head if I can. So 26 minus 1 is 25. 25 times 4 is 100, so we have 100 thirds. And then if I add 1 to that, I'm doing 3/3 plus 100 thirds, which is 103 thirds, which I don't believe I can reduce at all. Let me look over here with the answer choices. There it is, 103 over 3, n, so that's what 2 is. All right, the first two problems were kind of traditional, even though that last problem involved some fractions. Question 3 is getting a little bit outside the box now. They're giving you the nth term, it's -84. They're also giving you the first 3 terms of the sequence, but they want to find out what n is, like which term is this in this sequence. So we can actually still use our formula, a sub n equals a1 plus d times n minus 1, but instead of plugging in something for n, now we're going to solve for n, which means we need to plug things in for the other 3 variables, a sub n, a sub 1, and d. So a sub n, they told you it was -84. They kind of spelled that out. A sub 1, that's the first term, which is 6. D, the common difference, well, let's see what that is. 1 minus 6 is going to give me -5, so I'm adding -5 each time to get the next term. So we have a -5 for D. And then n minus 1, I'm going to leave that the way it is because we're still solving for n. Now I just have to simplify this and isolate n. So all this stuff on the left side can stay the same. I'm going to distribute this -5 for my next step, though. So -5n, and then we're going to have a plus 5. Next, I've got 6 and 5 adding together to get 11. If I subtract 11 over to the other side, that's going to be negative 95. And if I divide both sides by negative 5 to get n, I believe that's going to be 19, because 5 times 20 would give me 100. So 5 times 19 is 95. 19 goes with I, so that's what 3 is going to be. Number 4 is even trickier than the last one. Now they're giving us some the first and kind of the last term of a sequence, and they want the 3 middle terms. So you could try to reason this out and say, okay, what would I have to keep adding to get from 5 to negative 7 in a span of 5 jumps or whatever. You also could actually still use our formula, a sub n equals a1 plus d times n minus 1. If you're a little bit crafty about it, you can use this to find the common difference. You could probably reason it out another method, but I'm just going to go with this. So my a sub n I'm going to use is negative 7. a1 is going to be 5. My common difference, I don't know, so I'm going to leave that as d. And for the n value, well, I've got 5 terms here. That's how I got this negative 7. It's the 5th term, so I'm going to use 5 for n. So now simplifying this a bit, 5 minus 1 is 4, so this is a 4d that I've got in there. Subtract 5 to the other side, that's going to be a negative 12 over there. And then dividing by 4, I have d equals negative 3. So I have to add negative 3 to get the next term each time. 5 plus negative 3 is 2. 2 plus negative 3 gives me negative 1. Negative 1 plus negative 3 is negative 4. And just to double check, negative 4 plus negative 3 does give me the negative 7 that I'm supposed to end with. So this works out. Let me look for 2, negative 1, and negative 4 in my answer selection here. I see that all right here with O, so that's going to be 4O. For number 5, we're also finding missing terms, but it got a little bit trickier here because they're not giving us the first term. They're giving us the second term. They are still giving us the last term, though, the 5th term in this case. So I'm going to kind of use my approach from before, basically figuring out the common difference, the d value, and using that to figure out these other values based on what I have here. And I'm also going to use my original formula, that a sub n formula. I'm going to modify it a little bit, though. So instead of having a1, because I don't know what my first term is, I'm going to use a formula that has a2 in it. We're still going to be adding common difference, but this time instead of doing n minus 1, we're going to have to do n minus 2 in order to make this work. The whole point of this whole n minus whatever is that when you start with this term, you've already used up the first 2 terms, so your n value, which is the number of terms, needs to be decreased by 2 since you've already used 2 of those up. So we've got a sub n, that's going to be 44. A sub 2 is 8. Common difference we're looking for, so still d. And then n, we're using 44, so we have to use 5 for n, because that's the 5th term, so 5 minus 2. So I can simplify this now to 3d right there. Subtract 8 from both sides, we end up with 36 over there. And if 3d is 36, that means that d is going to be 12, 36 divided by 3. Using that common difference now, I'm going to go back to the original series, and to get my first term, if I added 12 to get 8, that means I have to do 8 minus 12 to go backwards. So that's going to be negative 4. And then 8 plus 12 going the other direction would give me 20. 20 plus 12 gives me 32. And then 32 plus 12, just to check it, does give us 44. So we need negative 4, 20, and 32 in my answer choices. That's going to be right here. That's an I. So then this 5 is I. For number 6, this is a different type of problem now. The next few problems, actually, they want us to find the sum of a series where they're giving us various pieces of information. This time around, they gave us the first term, 12, the nth term, 100, and it turns out that was the 12th term. They told us n was 12. So for all these, I'm going to start with my formula sum Sn equals, and we're going to have n times a1 plus an over 2. Basic idea behind this is I'm averaging the first and the last term together, dividing it by 2 after adding them, and then multiplying that average by the number of terms. So let's see what they gave us. They actually gave us everything we need for this exact formula. So I'm going to have my n value of 12, and then a1 we said was also 12, plus my a sub n, which is 100. And now I just have to enter all this in the calculator. So here I am on the calculator. For doing these sorts of problems, I like to use my fancy fraction mode. Alpha y equals and then n over d gives me this nice little fraction formatting. Pressing enter, that comes out to 672. And 672, that matches up with g, so 6 is g. For this next problem, we're again trying to find the sum of a series. They gave us the first term, the n value, and the common difference, which is interesting. So looking again at our formula, n a1 plus an over 2, we notice that we have the a1, we've got the n value, it's 8, but we don't have a sub n. We don't have the 8th term. So we're going to have to actually find that before I can use this formula. So to do that, I will go back to my sequence formula, rather, the nth term formula. A sub n equals a1 plus d times n minus 1. I have everything I need here to find the 8th term. So a sub 8 is going to equal my first term, 42, plus my common difference, which they handed to me, that was 6, times the n value, 8 minus 1. So that's going to be 6 times 7. 42 plus 42 is going to be 84. So now I can plug that along with some other information into this original formula up here. So I have an n value up here of 8. We have a1, which was 42, plus a sub 8, which was 84. All that over 2. Let me use the calculator. Plug in all that in. This comes out to 504. And 504 is going to be n, so 7 is n. For this problem, we're again looking for the sum of a series. This time they've given us the first few terms of the series and the last term. Now this is a small enough series that if you wanted to, you actually could just brute force it and write out the entire series and add it up. It wouldn't take that long. I mean, you've got 4, then 2, then 0, then -2, and so on. However, if you want to be a little bit fancier with this one, you could actually use some formulas. So here's our sum formula again that we could use on this. Now, if I want to use this formula, I don't know how many terms there actually are. I know the first term, I know the last term, I don't know n. So I actually would have to backtrack and use my other formula, the nth term formula, to trace back what the n value is. So if I'm doing that, my a sub n, that would be a -10. a1 would be 8. And my common difference, I'm subtracting 2 each time, so that's a d value of -2. And then my n value, I don't know what it is, so I'll leave that as n minus 1. Let me now simplify this and then solve for n. So I've got a -2 getting distributed. That's -2n over there plus 2. And let me solve for n now. I'm just going to subtract all the constants over to the left side. So -10 minus 8 and minus another 2 is going to give me a total of -20 over there. Dividing that by -2, I get an n value of 10. Going back to my sum formula then, I have 10, and then a1 again was 8, plus a sub n of -10, all that over 2. I don't really need the calculator here. 8 minus 10 is -2. -2 divided by 2 would give me -1. -1 times 10, -10. So that comes out to, let's see here, -10, that's an O right there. Now, another way you actually could have done this problem that would have been the fastest of all, since you know you've got 2, 0, -2, -4, -6, -8 over here, 8 through -8 actually are just going to cancel each other out since there's opposites. And then the only thing left over would have been this -10. So just another way to reason it out. For number 9, they are busting out the sigma notation for summation. So if you haven't seen one of these before, the basic idea here is you have to plug in all of the n values from 1 to 20, at least all the integer values, so 1, 2, 3, 4, no decimals though. Plug all those into this formula in here, and then whatever you get by plugging all those things in, and there's going to be 20 of them, you're just going to add those together. So that's kind of the long way to do it. There's also a calculator way to do it. I'm going to show you kind of a non-calculator, or at least low calculator shortcut for doing this. This is an arithmetic sequence or series here. The reason we know that, other than the fact that they spelled it out up here, is you've got a linear sort of relationship here. So your next term, you're always going up by 2 from the last term. You have a slope of 2 here. So what we can do is actually use our arithmetic sum formula. This formula right here, n times a1 plus an over 2. Now to make this work, I need to figure out n, a1, and an. Let me start with my first term. To get that, you have to take this lower limit of summation and plug it into this expression, which we call the summand. So we have 2 times 1 plus 1. Certainly not too difficult with the arithmetic. So we have a first term of 3 if I were to write out this whole series. And to get my last term, they always tell you the index number of the last term above the sigma symbol here. So 20 is what I have to plug in for my last n value. 2 times 20 plus 1 is going to give me 41. So we've got 3, 5, 7, 9, all of those up through 41. So now plugging all that into my formula, my n value, I actually still need to figure that out. So how many terms are there if I start at 1 and count up to 20? Well, that would be 20. So we have a 20 for n. Kind of a trick you can use is to do the top minus the bottom and then add 1. It's always 1 greater than the difference of these things, the way it works out. Now my a1 we said was 3. We have a sub n of 41, so all of that over 2. And I bet I don't need a calculator for this actually. 20 divided by 2 is 10. So we have 10 times, this is 44 in here, 10 times 44 gives me 440. 440 corresponds with G right here. So 9 then is going to be a G. So we have an ing at the end of whatever this solution is. Number 10 is kind of the same problem as number 9 was. We again have a sigma notation going on, a summation. We actually have fewer terms. We're going from 4 to 10. And by the way, this index letter can be whatever you want it to be. We still have a linear summand, however, so this is still definitely an arithmetic series. So I'm going to do what I did before. I've got my summation formula here, and I'm going to figure out n, a1, and an. a1 this time around is what I get when I plug 4, the first limit of summation, in for p. So we have 2 times 4 minus 3. That's 8 minus 3, giving me 5 for the first term of this series. And then for a sub n, I'm going to plug in my top limit, 10 for p. So 2 times 10, that's 20 minus 3 is going to be 17. So I've got an n value of what? If I start at 4 and count up to 10, well, 10 minus 4 is 6, and I have to add 1 when I subtract those. So I've actually got 7 terms. Feel free to count, though. We got 4, 5, 6, 7, 8, 9, 10 is 7 terms. Proved it. And then we have 5 plus 17 in there. I could probably do this without a calculator. 5 plus 17 is 22. Divide by 2, you've got 11. 7 times 11 comes out to 77. 77 is L, so 10 is L. For number 11, this one's kind of sneaky. They want the first terms, and by first terms they mean the first 3 terms, because that's what's in the answer choices here. And they're giving you the first term actually, so you just need 2 more. And they're giving you the last term, and they're giving you the sum of all the terms. So in order to figure out the first 3 terms with the first term thrown in for free, you need the common difference. To get the common difference, I'm going to need to use my a sub n formula. However, in order to get everything I need in that formula, I'm going to need to know the value of n. So to get the n value, I'm going to use the summation information they gave me and first use my summation formula, n times a1 plus an over 2. I'm hoping that I have enough information to go back and solve for the n value. So plugging things in, I have an S sub n of 900. That's the sum of the whole series. The n value we still want to find out. A sub 1 was 7. A sub n was 83, so they gave me that. 7 plus 83 is 90, divided by 2 is 45. So I can rewrite this right side as 45n. And then, well, let me think. 90 divided by 45 would be 2, so 900 divided by 45 is 20. So we have an n value of 20. This gives me enough information to now go back and use my nth term formula right here. And I can use everything I have now to go back and solve for the common difference. So my a sub n again is 83. We have an a sub 1 of 7. D value is what we're looking for, so that will remain a variable. N we just found was 20, so 20 minus 1. 20 minus 1 is 19, so we have 19d. And then if I subtract 7 from the other side, that's 76 over there. 76 divided by 19, I believe, is 4. Let's see, 4 times 10 is 40, 4 times 9 is 36. That adds up to 76. Yep, 4 without a calculator. Nice. Now I can go back and actually figure out my first 3 terms. My first term they gave me for free, that was 7. After that, I have to add 4 to get the next term, so that's 11. And 11 plus 4 again gives me 15. 7, 11, and 15 is right here. This is choice M, so that's going in 11. We're on number 12 now, the final problem. They still want the first terms of a series. This time around, they gave us the number of terms. They also gave us the nth term and the summation. So again, I need to find the common difference. And if I'm going to be using that other formula, the nth term formula, I'm actually going to need the first term in order to make that work. So this is going to be a little tricky. Let me start with my summation formula and see if I can use this formula to find a sub 1. Once I've got that, I can use a sub 1, n, and a sub n to figure out the common difference. So this time around, I have a summation of negative 120, n value of 16. They gave it to us this time. A1 I don't know. A sub n is 15. And let me do a little bit more here now. I got a little bit fancy on my next algebra move. 16 divided by 2 is 8. And then I just divided both sides by 8 to get this parentheses alone. Negative 120 divided by 8 comes out to negative 15. Now I can just subtract this 15 and get negative 30. And yes, I do kind of feel pleased with myself at how cleanly that worked out. So let me use my a sub n formula now. My a sub n value was 15. A1 we just found was negative 30. The d we're looking for, and n they gave us, was 16. 16 minus 1 is 15, so we have 15d. Add 30 to the other side, we have 45 equals 15d. And then dividing by 15, we have d equals 3. So my first term, we figured it out actually. It was up here, it was negative 30. To get the next term, I have to add 3, so that's going to be negative 27. And then 3 added to that gives me negative 24. So there's my 3 terms. T, that goes in 12. At this point, I'm ready to solve the puzzle. I filled in all the letters. The puzzle again was, what is the sun's other job? And the answer is moonlighting, because the moon does get lit up by the sun, and if you work another job, it's called moonlighting as something else. I think because your other job, you're typically doing the night shift or something like that. Anyway, till next time, Mr. Sutton signing off. Time to get back to my day job here.